Today we'll be taking a session on Doppler effect. So can I know what's the preferred mode of communication for this specific webinar right now? You can type in the chat box. Yeah, so I'll be proceeding in English right now. In the meanwhile, if somebody has a problem with that, they can let me know. And yeah, so we can work with both Hindi and English. That's the usual consensus right now. So we'll be starting the webinar now. So me and Sarthak are in JarWiz team, which is a team which is participating in NASA HERC. If you want to know more about that, you can look up our social media and all. And yeah, we'll be starting the session now. Sarthak, you can take it from here.
Okay, so hello everyone. Today we will be understanding the basic Doppler effect and the applications it has. So you guys are comfortable with English, right? As you mentioned. So I will be explaining some little bit things in Hindi. So first, let's come to the basic Doppler effect, what it is. So when any type of waves approaching you or retreating from you, you face the Doppler effect. So if a wave, say, is approaching towards you, then you will face an upward shift, while if a wave is retreating towards you, you will face a downward shift. So a basic example can be seen. Imagine an ambulance going and two observers on both ends of the ambulance. So when the ambulance move forward and it uses its horn, so for the person where the ambulance is moving, he would face an upward shift and high frequency waves, whereas the person who is behind the ambulance would face the downward shift and low frequency waves than the originally it's emitting. Also, it can be seen in the ripple effect that if you drop a stone in water, the rings of foam, so the closer to the stone, the closer to the source, the rings are closer to each other and the distance increases, as you can see. Now the Doppler effect applies on following waves. Basically, it applies on any type of longitudinal and transitional waves, but we would be studying mostly about sound waves, light waves, and water waves, as I gave an example. So the concepts of Doppler effect. To understand the Doppler effect, we have to study these three basic. You would already know wavelength, frequency, and velocity, but let's again study them a little bit. So wavelength is basically the distance between two consecutive crests of a wave, and its mathematical formula is the speed of the wave upon frequency. And frequency is basically the number of occurrence of repeating events per unit time. So basically the number of waves formed per unit time can be called frequency. It's measured in hertz and its units are 1 upon time. And velocity is simply speed in a particular direction. So if two cars are moving in opposite direction but with same speeds, we can consider it's minus 25 meter per second plus 25 meter per second. So any doubts till now? If there are any doubts, you can ask in the chat, because after these we will be understanding some equations which would be a little bit difficult. So if you have not understood these concepts,
Yeah, so these can basically be said that these are the root concepts which will help us understand the further concepts of Doppler shift and where we can see them and occurrences and uses and all. So if you have any doubts in these, please ask. We'll clarify them right here.
so I will be moving forward as I cannot see any doubts. So now let's come to equations. So basically, as we learned that the frequency of the waves changes according to the placement of the observer and the placement of the source. So in this equation, we are considering, we are symbolizing O as the observer and S as the source. So the apparent frequency is equal to the original frequency into V plus minus V naught upon V plus minus Vs. The notations are given below. You can see that V is the velocity of sound here, or if you are talking about light waves, it can be the sound, it can be the speed of light, plus minus the speed of the observer upon speed of sound minus plus the speed of the source. So how do we judge the plus and minus signs? Basically, if you are facing an upward shift, you will be using the signs plus minus, while if you are facing a downward shift, you can be using sign minus plus. It's a very easy equation, nothing to कुछ खतरनाक नहीं है इसके बारे में. बेसिकली बहुत ही आसान सी क्वेश्चन है. If you're facing an upward shift, you are facing high frequency, so plus would be upward and minus would be in the denominator, and vice versa for the downward shift. You can note if you want to note this. Moving forward, now is the main thing and most interesting part, Doppler effect in light waves, which is also referred to as the Doppler shift. So Doppler shift in light occurs the same way it occurs in the other waves, or the, as we read in the sound waves. If you are facing an upward shift, it is referred here as blue shift, while if you are facing a downward shift, it is referred here as the red shift, in which the higher frequency changes a little bit to the lower frequency. So redshift was first experienced in the galaxies when light from distant galaxies, when we study the spectrum of the light from distant galaxies. As you can see, these both spectrums, this is the absorption lines from the sun, and this is from a supercluster of galaxies, and this is distance 1 billion light years away from here. So as you can see, these lines are not coinciding. That means it has a little bit shifted towards the red side. So from this only we this was the first proof that the universe is expanding. From here we learned that universe is expanding at some rate and it's not constant. So the Big Bang theory and the expansion of the universe came from this redshift, and then there were other theories to support them. Okay, now I have prepared some examples for a better understanding. This is gravitational redshift, and this experiment was called Pound-Ripka experiment. Here what happens is, in a building where on Earth, we they send gamma rays, but let's consider that these are normal photons. So for your understanding, I have made this blue and red. It's not that it doesn't changes this much. I'm exaggerating a point to show you guys. So for different observers along the building, we can see that the blue changes to the red here. The blue waves, when they shot the beam from the ground and send it above, for the observers it changed from blue to red. And same experiment can be seen in a rocket. If we accelerate a rocket with the acceleration of g, and we place 3 different observers here, we can see that the blue light changes to green and then to red as the velocity increases. This is called this is your basic gravitational redshift. This occurs because the source, you are moving away from the source. Basically, if the rocket is accelerating and the source was here, at some time the rocket would be somewhere here, so you're moving away from the source. Now let's consider an observer at rest outside the rocket. Now these were moving with the velocity of the rocket, these observers. Now if we consider an observer outside the rocket, we see that he only sees blue light. For him the shift doesn't happen. So how could this be? मतलब ये कैसे हो गया कि तीन ऑब्जर्वर के लिए तो शिफ्ट हो रही है, बट एक ऑब्जर्वर जो बाहर है स्टेशनरी, उसके लिए नहीं हो रही. So this happens because the shift which we are studying is relative. The wavelength and the frequency which we studied aren't the intrinsic properties of photons or gamma rays or any type of rays. They are basically a part of the observer and the wavelength system. So we always study them in a system. The light doesn't actually changes its wavelength. Just as an observer, we see the wavelength is changing.
Yeah. So to elaborate Sarthak's point here, what he's trying to say basically is everybody in this particular system will perceive light as a different wavelength, because the observer, the source, everything is different for everyone. There is motion relative to some objects which isn't relative to other objects. So that's why we would someone would in the system would perceive a change in the frequency of light, whereas the other person would not perceive the set change in light because there is no relative motion. Relative motion is what actually causes the Doppler shift, and if there is no relative motion with respect to the source of the object, no matter what is the source in this case or what is the object in this case, there will be no uh, Doppler effect, so to speak. Am I right, Sarthak?
Yes, yes, you're absolutely right. And for the previous experiment that we studied, if a person is free falling, he would also observe the same thing, because if he's free falling with the acceleration of g, this would be represent almost the same experiment. So even he would notice that the shift is happening. Now let's come to cosmological shift. Now what this is, if we're not considering this Earth or a galaxy or a cluster, but if we consider the whole cosmos, everything is basically isotropic, everything is homogeneous. This is called a cosmic fluid. You see up, down, anywhere, you see the same things. So if here we consider two co-moving observers are basically observers that are constant to the speed of the expansion. We are not co-moving observers. Our galaxy is moving 600 kilometer per second in the in the opposite direction to the expansion. So if we consider two co-moving observers which are expanding with the universe, and a beam of light is sent from one and received other, we will notice that this blue light changes to red. Now this is called your basic cosmological redshift. But now if we consider, wait a second. Yeah, so basically now if we consider that there are more in between them, there are more co-moving observers. Let's take them like these. These are the galaxies. From here, if a blue light is emitted and absorbed by this, then a green light is emitted, then absorbed by this, then a more color change light is observed, and in the end it produces red light. Now this is also the shift, but this is due to Doppler shift, due to the basic change in velocities of the light. This isn't because of the cosmological redshift. So technically there aren't like 3 or 4 redshifts. There is only one shift. It depends on the perspective of the observer, from which point of view is he observing it. Now let's come to some applications. Does anyone have any doubt in this all? कुछ कुछ समझ ना आया हो तो पूछ लो. बिल्कुल वैसे तो बेसिक सा बताया था. Okay, no doubts. So let's come to the applications of Doppler shift. So as you will Doppler shift is used in the fluid flow analysis. So basically this is the whole setup, and there are two types of velocity meters: one acoustic Doppler velocity meter ADV and laser Doppler velocity meter LDV. So the ADV emits ultrasonic sound waves, and LDV emits a light beam in a fluid flow, and from that we calculate the wavelengths of the fluid flow, and basically we analyze that what type of flow it is. And it is used in radar. You may have seen in movies, or maybe in India I have not seen, but when the police have to catch a car, or like they are testing the speed, they use a device like this, and the speed occurs in that. So basically they are sending a radar to the car, and when it reflects back, it calculates the speed. It is also based on Doppler effect. It is also used in aerospace navigations, where if you are in an aircraft, you can calculate the speed of flying objects around you, like drones or plane jets. No, and most importantly, as we studied earlier, it is used in astronomy, where you calculate the speed of expansion, or from what speed our galaxy is moving or other galaxies are moving from each other. This all is calculated by the Doppler effect. So I don't think you will have any doubts in this. These were basic explanations. Now I have a question for you guys. Now, as we studied about this, so the first piece of evidence that was shown about expansion came from the redshift. And so I want to ask one thing, like if the universe is expanding, do you guys think that are we expanding too? If the whole of the universe is expanding, are we expanding too? Does anyone have any views on this? You can type in the chat box. That do we expand with the expanding universe? sometime or slowly or do not at all. Anything? Okay, so I'll give an explanation for that. We don't technically expand because
Sarthak, I think Ravinder wants to say something. He says in
okay,
chat, no, we are not expanding. The rate of expansion is extremely small uh, at small scales.
yeah, it's
So,
almost there.
Rupinder, do you mean that we are actually expanding, but the expansion is so minimal that we are unable to notice it, or there is no perceived change during our lifetimes? Infinitesimally
Infinitely
small.
small. Okay,
Yeah, I think
there
we
are
should
basically
clarify.
two theories. One which the Rupinder is saying, and the other thing is that no, we are not expanding because everything we studied about expansion and cosmological redshift, we consider that as a homogeneous area. But if on Earth you are standing, you see up, down, everything is different. So we cannot do the same assumptions for that we do for the universe for us. So we're not technically expanding, but if even you leave yourself in the universe apart from Earth in the cosmological fluid, then also you will not expand. This is because our body has some electromagnetic forces that hold the body together. So, but if we remove those forces, yes, you will expand. With time, you can expand, but this is only because our whole universe will be then, if we remove the electromagnetic forces, whole universe will be guided with the dark forces. So that's why. Okay,
Any doubts
now
or
we
any
have a.
views on that? Anyone?
Yeah, Rupinder, would you like to say something to that?
Yeah, I mean, not even Rupinder. Anyone who has joined the
Yeah,
session, you are free to express your views right now.
I think it's mentioning depending on forces acting between the objects' bodies in question. Universe is expanding because the only thing holding it together is very weak gravitational force. Please correct me if I am wrong. Your explanation is correct. Okay. Yeah, Sumit, wait. Yes, Sumit, you are correct. There is nothing wrong with it. I what I just said was added to these points only. Yes, you are not wrong. Okay, now as mentioned earlier, let's. Uh, anyone has any doubts? I am asking last time. कुछ भी पूछना हो या कुछ अपनी व्यूज देने हो तो दे सकते हो.
किसी और की कोई थ्योरी? I think that there are
Yeah,
no doubts. Yeah,
yeah,
so we
okay.
can continue.
So I will be giving you a link. From that you can open the quiz and answer. It's a very simple quiz, 10 questions.
Yeah.
I don't think it would be that tough. You can do it. Okay, I'm pasting the link in the chat box. From that everyone can give the quiz.
And also, I think we forgot to mention that if there are any doubts or if there are any queries in the questions presented in the quiz, you can also clarify them here. Yeah, I think that we have a question, Sarthak. Kavya asks, what will happen if the astronauts will not exercise regularly in space? Will they expand? Well, the answer to that question is sort of yes and a no, because yeah, they will expand in space because they will collect fat because they won't be exercising as much. The rate of degradation of bones in space is really high because of lack of gravity, and also the consequences of zero G on the heart are pretty tough. The heart loses its ability to pump to the head to a certain extent because there is no gravity. So yeah, the astronauts should expand because they won't be exercising as much because they get fat, so to speak. But yeah, due to Doppler shift, no, they won't. And due to expansion of universe, I don't think that they will.
Shan
They
asked,
won't.
what is the speed of expansion? The speed of expansion is roughly around, I think, 66 kilometer per second. Okay, Rupinder said 70 kilometer per second parsec. Yeah, somewhere around there, somewhere around 66 to 75 plus minus, because there are some errors plus minus 2%. So yeah, somewhere around that.
Yeah.
Once you guys finish the quiz, you can mention it in the chat box. We can confirm from there. Okay.
Okay, so is there anyone who was facing some trouble or some issues answering the questions in the quiz? Okay, so since I think that most of you have completed the quiz, we'll be ending the session here. But don't forget to join uh, other members of Team JarWiz in their next presentation, which is about military applications of UAV. Uh, that session will be given by some pretty good guys in our team, and I highly recommend you join that session because there you will be able to learn something which you probably wouldn't learn anywhere else. So,
Yeah, and the link to that webinar is already
uh,
in the chat box. From
yeah.
that, you can register. And
So, thank you for being our patient audience here, and we'll be taking your leave. Thank you.
thanks, everyone.
Thank you.